Today we're going to have a small pre-calculus talk. The next talk in calculus will be on inverse trigonometric functions. So I thought maybe just a short review of the ideas of inverse trigonometric functions might be a good idea. So, first of all, before you talk about the inverses, we have to discuss what the regular function does. So let's pick the sine of x. What does the function y equals the sine of x do? Well, the independent variable, what you're putting into the function, x, in this case is actually an angle. And you can measure it in degrees or radians. Radians is probably the best way to talk about it now because all of our calculus derivative and antiderivative formulas have been derived in radians. So we're going to measure our angle, and the angle is measured from the x-axis positive in the counterclockwise direction. So this would be an angle x right there, and that forms a right triangle. And there's actually a point right here, xy, in the xy coordinate system. So what this function does is that you give it an angle and it gives you the ratio of this side of the right triangle to this side. So, and it doesn't matter the radius of the circle, so often, since if we use a unit circle, a radius 1, then when we talk about the ratio of this side to this side, it just really becomes that side of the right triangle, or in this case, y. The y value in the xy coordinate system. So, for instance, if you put in the angle right here to be 0, that means this y distance right there is going to be 0. So you get a point 0, 0 on your graph. If you were to put in the angle to be pi over 6 or 30 degrees, from geometry, we know that this opposite side is going to be half as big as the hypotenuse. So this is going to be 1/2. So when you get to pi over 6, you get to be 1/2. And that's another point on the graph. And then when the angle gets up to right here, now the y value is the same thing as the hypotenuse. So the ratio is 1:1 or 1. That's just a little bit of review what the sine function does. Now as you get the angle past pi over 2, now it starts, the y value goes back from 1 back down to 0. And then all the y values down here, once you get past pi radians, then all the y values, if you were to make a triangle, are going to be negative values. And that's why you come down, you go to -1, 1, and then when you get to 2 pi, it just repeats all over again. So now we're just going to go up and down. And if x is measured in a negative amount of radians, then you're going to go clockwise. And now you can see right away you start out with negative values of y. So if you went to negative pi over 6, you'd be at a -1/2. And then when you go to negative pi over 2, down here you're at a -1. And so you kind of complete the graph to look something like that. So anyway, it definitely is a function. Every x value has one y value, so it's a function of x. But if we want, and the domain of this would be all real numbers, and the range would be from -1 to 1. So it'd be -1 is less than or equal to y, is less than or equal to 1. And we're interested in that because we're going to talk about the inverse sine function. So the inverse sine is going to do just the opposite of this. The range and the domain get switched around. But unfortunately, if you did that, then you would have the x's and y's get switched around. And now you would have something that would not be a function, because this is not, the sine function itself is not a one-to-one function. Every x has one y, but the y values have a lot of different x values. So if you took a given ratio, there's a lot of different angles that would have that same ratio. So in order to have the sine function to have an inverse, we've got to restrict the domain. So what portion of this graph could we get that takes on all of the different ratios but doesn't repeat any? Well, if you go from negative pi over 2 to pi over 2, if you just take this section of the sine function, then it will be one-to-one. Every x value has one y value, and every one y value has one x value. So that's what we're going to do. We're going to restrict the domain to be negative pi over 2 to pi over 2 for the x values. And this is really important because now when we go to the inverse sine function, the domain is going to become negative 1 to 1, and the range is going to be from negative pi over 2 to pi over 2. So if we were to graph it, the range would go there, and the domain would go from negative 1 to 1. And everything gets switched around. So the sine of 0 is 0. The sine of pi over 2 is 1. So the angle whose sine is 1 would be pi over 2. So instead of getting the point pi over 2, 1, you get the point 1 pi over 2 on the graph. The angle whose sine is 1/2 is pi over 6. And the angle whose sine is 0 is 0. So you get there. The angle whose sine is negative 1/2 would be negative pi over 6. So that would be down here at negative 1/2. And the angle whose sine is negative 1 would be negative pi over 2. So there would be the graph of the inverse sine function. Now you're probably in your calculus class not going to have to be able to graph that. What you're going to have to be able to do is figure out what is the angle whose sine is 1/2. So that's why this domain and range is so important. Because as soon as I see the ratio is 1/2, where are you going to go to look for the angles? Since it's positive, you're going to go in the first quadrant. You're going to go from 0 to pi over 2 to search for those angles. So right away, if you don't have your automatics memorized, which isn't always such an important thing, you can quickly go from 0 to pi over 2 and draw in what that angle would look like. So if it's 1/2, you know the ratio has to be 1/2. I'm not actually drawing in the circle, and I'm not even making it a unit circle because to me it was easier to make this side 1 and this side 2. In any case, we know that that's from geometry that's a 30-degree angle, or pi over 6, and we've got our answer. Because when you do calculus problems, you're going to come out at answers that turned out to be the inverse sine of 1/2, and you have to be able to quickly figure out what that number is. What if you get the inverse sine of negative As soon as you see it's negative, we see all the negative ratios. The answer has to be between 0 and negative pi over 2. So we're down in the fourth quadrant. So right away, I can say my angle is going to be right here. And the ratio is negative 1 over the square root of 2. So it's this side, negative 1 over the square root of 2. From geometry, we know this side would also be 1. And since these two sides are the same, that must be a 45-degree angle, or negative pi over 4. I'm going to spend more time on the inverse sine than the other two. If you're talking about the tangent function, the ratios become different. The function is a different function. X that you plug into that is still the same angle. But now the ratio, instead of being the opposite over the hypotenuse, it's going to be the opposite over the adjacent in that right triangle that you form in that circle. So now it's going to be, if you call this point right here xy, the ratio is going to be y over x. So you can see when the angle is 0, the y value is 0, so the tangent would be 0. When you get to pi over 4, or 45 degrees, this side would be the same as this side, so your ratio would be 1. And then, as you get closer and closer to pi over 2, your ratio of y over x, the x gets really small, and when you divide by something really small, it tends to make things really big. So you get a really high, it approaches infinity. That number gets really big. And if you go in the other direction, I think you all pretty much know what the tangent looks like, but then it starts repeating itself. So you get all these other sections like that. But if we're looking for an inverse tangent, we only want to use a 1-to-1 part of the tangent function. So if we just use this, it gets all of the ratios we could ever want, but it doesn't repeat them. So we would only use this part. And again, it's from negative pi over 2 to pi over 2. So the tangent, again, has a range that normally would go all the way from negative infinity to infinity, but we're going to restrict it to let's see. We're going to restrict the domain to negative pi over 2 is less than x is less than pi over 2. And that's important because that's going to become the range over here. So for instance, if we want to get the inverse tangent of negative 1, we're going to have to go into the fourth quadrant. We know that all the inverse tangents have to be down here. All the negative ratios are going to be between 0 and negative pi over 2. So right away, when I see that's negative 1, and my ratio has to be negative 1/2, I can see that this angle has to be negative pi over 4. Anything that would be positive, any ratio that you'd put in here, the inverse tangent of any positive number is going to turn out to be an answer between 0 and pi over 2. And those are probably going to be the two most important inverse functions. But just to quickly show you that the range doesn't always come from negative pi over 2 to pi over 2, if you were to take the cosine, I think you know the cosine function goes like this. So in order to get all the ratios from negative 1 to 1, now instead of to get a 1-to-1 part of the cosine function that gets all of those ratios, we're going to go from 0 to pi. This portion right here. So on the inverse cosine, the range is going to be from 0 to pi. So that means if I'm looking for an inverse cosine of a positive number, I'm going to go from 0 to pi over 2 to look for my answer. But if I'm looking for a negative number, I'm going to go from pi over 2 to pi. So if I'm looking for the inverse cosine of negative 1/2, I'm not going to go to the fourth quadrant, I'm going to go to the second quadrant. And what is that angle going to have if the cosine is negative 1/2? Then we know that this angle up here is a 30-degree angle, so this is going to be 60, so you're going to be at 2 pi over 3. So anyway, this is the type of thing you're going to have to be able to know how to do, but I thought it was worth showing you where you had to go to find these inverse trigonometric relationships. So, in the next talk, we'll actually talk about the calculus of inverse functions, inverse trig functions. Thank you.